So this lesson, we're going to be doing basically the same thing as last lesson, but we're actually going to have to create the tables from information in a paragraph. So this is, there's two ways you might be doing this if you were at a job or just trying to figure something out on your own. If you were the person that was supposed to read after someone made a chart, like you had to look at a chart and make decisions, that's one possibility. But you could have also collected the data or had it, kind of messy or not organized in a table yet, and you would make the table so you could start to calculate probabilities. So this one says, in a math class with 22 students, a test was given the same day that an assignment was due. There are 14 students who passed the test and 17 students who completed the assignment. There were 12 students who passed the test and also completed the assignment. What is the probability that a student randomly chosen from the class did not complete the homework? So one thing that's kind of weird here is we're going to assume that homework and assignment mean the same thing. I cut and pasted these directly from Delta Math, and I think maybe it was just a typo there. So the first thing we do is we notice that we have two things. We have the test and we have the assignment. So this is a good chance to make a two-way table, which is what these tables are called that you saw from last lesson. So we're going to draw it out. And when there's two different events, you can do this with more than that. The tables are always 4 by 4, basically because you have your title and you have your totals and you have the information in between. So here's my totals. You can put either event, the test, or the homework in either the top or the side. You can pick. I'm going to do passed and not passed. And I'm going to do homework, which is assignment, or no homework this way, but it doesn't really matter. So from here, 14 students passed the test. That's our first piece of information that we're going to put in the table. So that 14 goes in the bottom of the passed column. Okay, it's nothing about homework, so we just put it right here. We have 17 students who completed the assignment, so that goes at the end of the homework row or assignment row. There were 12 students who passed the test and also completed the assignment, so this is an and spot, so it will go in homework and passed. And then the last piece of information, which I kind of skipped over, is that we have 22 total students, so that 22 just goes in my overall total here. So from here, it's mostly just addition and subtraction. So I'm going to do this in a different color. So if there's 17 total people that did their homework, 12 of them passed, that means 5 of them, or 17 minus 12, didn't pass. In this direction, we have 14 minus 12 is 2, so 2 passed and did no homework. Over here, and you can really do this in any order that makes sense to you, there's 14 that passed and 22 people total, that means 8 didn't pass, and then this would be a 5. And then lastly, we have a couple ways, and we should check and make sure they both work. If this is an 8, right, 8 minus 5 is 3. And 5 minus 3 is 2, so we see, or 2 plus 3 is 5, so we see it works in all directions. So if you need to look back, the red things were the things I knew, the blue were the things I found initially, and then the 3 is something that I could check in multiple directions. So now on to what we're trying to find. We want the probability a student randomly chosen from the class did not complete the homework. So no homework. So if I look for this part, I have no homework is 5, and it's out of the whole class. There's nothing about a given or conditional probability, so that's just 5 out of 22. So moving down the page, look at the next one. Similar situation. I'm going to kind of draw my table a little quicker, and towards the end of the lesson, I'm actually going to have the tables ready to go, so the video won't be quite so long. But I think it's important that we make sure you guys can fill them out just as we start out. So I'm going to go with, I know what the situation is. So I'm going to draw my table. Totals. This is actually the same type of situation. We have an assignment. We have a test. So I'm going to keep it basically the same. So this is passed. And just to show here, I think last time, just going to look up the page, I wrote passed and not passed. I mean, we don't usually say not passed. You can write a different word for that. Like you can write failed here. And this is homework and no homework. So from here, the information I'm given, we're going to try to keep in red. So this is also a class of 22 students. 13 passed the test. 17 completed the assignment. 3 failed the test and also did not complete the assignment. So here this is an and, so it's failed and no homework or no assignment, so that's a 3 there. So now we can start filling in just with subtraction. It looks like I should start probably on these outer column and row. So I have a 5, an 8. If this is an 8 and that's a 3, this is a 5. And then we can go back across. I'll do this one first. This is a 2. This is one I can find in 2 different ways. So this is, it looks like I made a mistake here. So this is kind of a good chance to see. I'm going to look through my numbers. Where could I not add? Oh, it looks like down here I made a mistake. So this one needs to be a 9, right? Which means that this one up here needs to be a 6. So 13 minus 2 is 11, 17 minus 6 is 11. So this was just an example of if you make a little mistake, at the end you should be able to see it and be able to fix it because we want to make sure that this works in both directions. So now on to our probability. It says, what is the probability that a student did not complete the homework given that the student passed the test? So this is probability no homework given they passed. Okay, so our given, or the thing we know has to be true, is the past. So we've restricted ourselves just to this column. And here, no homework in this column is a 2. So we have 2 out of the 13, right? Because once we're doing a conditional probability, we can't use the 22 anymore. So this is 2 out of 13. Okay, so let's look at one more on this page. We'll move down to it. So this one has to do with the gender and the grades in the class. And you'll see on Delta Math, it's pretty cool the way he made it. It's a computer generated question, so he has a bunch of situations and it just kind of plugs in different numbers, and that's why you guys get the different questions. But he doesn't have, when there are these paragraph questions, right, he can't have an unlimited type of situations or it would take really long to do. So you'll see a couple, the situations kind of repeat, but the numbers change. So we have female and male is my one part. So female, here's some totals. And then we have an A in the class is another thing I say, or does not have an A in the class. So this is A and no A. So information we know in a class of 28 students, 9 are female, 5 have an A in the class, and there are 17 students who are male and do not have an A in the class. So here's male and no A, so the 17 goes there. So then we fill in our other information. We have 9 plus 19 would be 28, 5 plus 23 is 28. In this direction we have a 6. In this direction we have a 3. So then my last one is always that one I can check in 2 directions. So it looks like it should be a 2 and a 2, so that's good. Okay. So our question for this one is, what is the probability that a student chosen randomly from the class is a male? So that's our question. A male who does not have an A. So this one almost kind of looks like it's conditional, but they're asking me what's the probability that he's a male and also does not have an A. Okay, it doesn't say either of them are given. It doesn't make it sound like I already know one of them. I'm trying to find a male and A, or and not A. So this is probability of male and not A. And there's a large part of this that's reading, like reading comprehension, so I understand if it gets maybe a little tricky to see what they're asking for. So the total here, we don't have conditional, no givens. We still have, so we're going to have 28 on the bottom, and then male and not A is right here. So on this one, we actually could have figured it out without the table because I see that both the 17 and the 28 are red, right? So they're both information we had, but usually filling out the table can kind of help you organize things. So that's my final answer. So my suggestion on this page is to do all 3 of the questions and then come back and check them. So I would pause the video, just try them, draw out your own tables, and then we'll quickly go over them. So here's my table filled out for the first question. Note that this green part I have here, that the last thing I found was the 2. You could have found something else last, but whatever that last thing is, you should be able to check. So this question says, what is the probability the student does not have an A, given that the student is female? So we have a given here, so no A, given female. So that means that we want to just look in the female column, right? So my total is 5, and no A would be a 3. So this is 3 out of 5 for our answer. So this question is kind of a tricky one because it's a given without saying that word given. So it says, what is the probability that a student who has a brother? So they didn't say, does the student have a brother? They said the student does have a brother. So that's given. Student has a brother, also has a sister. So the given information here is that they have a brother. So we're finding the probability of a sister given that they have a brother. So if this was an and probability, which would probably be the thing that you might think it is, it would have to say, what's the probability you choose a student who has a brother and a sister, or what's the probability the person you choose has a brother and also a sister? Like there would have to be that thing where both of them are something that we're looking for, but here they're telling us who has a brother means we know the person has a brother. So we're only in the brother column because that's what's given. We want sister out of the total, so this is 14 out of 16. So this last one has to do with whether or not the person has a cat or a dog or both or neither. The question asks me what's the probability that a student randomly chosen from the class has a cat or a dog. So remember when we do or, that's kind of our trickiest one because we have to include